This is the National Standard of Liquid Measurement Flow, or PNFL by it means in Spanish, Patrón Nacional de Flujo de Líquidos, located at CENAM. We need to take care of more than 200 signals each day to guarantee the proper functioning of the system and to take care of our metrologists while the system is on. So let's move on and take a look at to get to know how it works. As any other system, we have a lot of different elements, each one of them with different requirements and a software that collects and processes those signals. Therefore, we have a multi-input and a multi-output system. You can find analog or digital signals, protocols, or counters and more. Usually, those elements are inside of our softwares, as well as the coefficients and any other data that modify the raw number into the expected magnitude, or for example, the function of a valve to change the value to open or close. Then, our software is just an intermediary of our sensors, valves, coefficients, and most of the data related to our calibration system. The problem consists of maintaining up to date each of these parts. It's common to double check if the values were introduced correctly, if the certificate is up to date, and overall if the system is acting as expected. Generally speaking, we could define each of these elements by its properties, including type of communication, wiring, location, maintenance, verification, certificates, photos, etc. We can include the error, uncertainty, or any other detail like who or when. So let's focus on all the information necessary to define every single element as one. It doesn't matter if it's a certificate, a sensor, a valve, or an engine. And because of that, I would like to see this element in detail because it represents any of them. Okay, here we are. This little body over here needs an identity, a name, a unique ID. After that, we can fill in as much information as we want, or as it could be able to fill in, and associate all of that with our partner over there. Now, we can do the same with any of the elements involved during a normal or during an extraordinary calibration. After that, we can put everything in a single place to know where we could find them. Perfect. It's time to connect our software to our main database to read or write that information because we can find everything there. Now, let some others play with us. Temperature, pressure, time, mass, humidity, or whatever you are thinking about. We are all connected and we all know where to look for information about any sensor or certificate. Of course, the term we is defined as any human or computer. And remember our first way to connect our software? Well, we don't need it anymore. Once that we are connected, we can be up to date in real time. If someone is calibrating a sensor that I need, well, he or she is basically updating my system while the calibration is in progress. The idea more or less looks like this. Imagine a system or a company or a country connected. Yes, you're right. We are thinking big and trying to make it global. EUROMET, the first metrological ecosystem to collect, to analyze, and to integrate any metrological element. This way, it won't matter if your sensor is here or there, if it is traveling more than you, if it is in an international comparison, or if it is being calibrated in a laboratory next door. Your system will be always up to date, minimizing human intervention, minimizing mistakes, optimizing time. EUROMET, simple, trustworthy, in the world. Because we care of you. Mistakes happen. Everyone knows that. Everybody makes mistakes. Even when you are focusing too much on something, it means that at the end of the day, maybe all what you have done is compromised, and now you need to spend time fixing it. That's the main reason why we're investing time to develop an infrastructure to link any system to any metrological component. Yes, it includes certificates. We started with the PNFL, and we're going to try it at CENAM. We are going to modify and adjust whatever needs to be modified to minimize problems.